This is LuxDMX. It takes Art-Net or sACN off your network and puts real galvanically isolated DMX512 on the wire. And the light in the corner there is not decoration. A console sent a show to the box put it on a DMX cable, and an analyzer at the far end of that cable recorded every frame. That render is driven by those frames. What you see is what came out of the socket. You do not need special hardware for most of this. A $5 ESP32 and a €2 RS485 module will do. One thing to watch: for RDM, get a module with a direction pin, not the auto direction kind, because RDM has to turn the line around to listen. An ESP32S3 is under $10, and one with a bit of PS RAM reads a lot more fixtures over RDM. Without it, the RAM caps the table, which in practice is still plenty. There is also a proper board. 2 isolated universes on 2 XLRs, wired Ethernet and Wi-Fi power over Ethernet or USB-C, a 5 LED panel, and a header for a small display. The outputs are protected. Plug mains into an XLR and a protector blocks it in under a microsecond. Then the output recovers by itself. Open hardware, so the design, the bill of materials, and the gerbers are in the repo. First boot, it opens its own access point with a captive portal. You either hand it your Wi-Fi or you let it stay its own network so a laptop or a tablet can talk to it with no router at all. On a board with a socket, you just plug in Ethernet instead. That is the whole setup story. Then you open it in a browser, and this is the part that made me build the thing. All 512 channels live at the actual frame rate, not a status LED and a hope. Up here, it tells you how it is doing frames per second, coming in, timing jitter, free memory, uptime, and whether it is on Wi-Fi or wired. The grid is the whole universe. Every cell is one slot, and it moves with the show, so you can see at a glance whether channel 300 is getting anything at all. You can name channels, front wash left, and it sticks in the grid, in the changelog, everywhere. And you can take a channel by hand, handy when you're on a ladder with a phone and nobody is at the desk. Quick values, and identify which flashes one channel to full for a second and a half so you can find out which fixture that actually was. Blackout is one button for when something is wrong and you want it dark right now. It also lists every sender it can hear with each one's frame rate. That is QLC plus over there, running the Q stack you saw at the start. If 2 consoles start fighting over the same universe, you get told, instead of wondering why the rig is twitching. You can pick what should happen when that occurs. Highest value wins, latest wins, or let them fight. Settings live on their own page, folded up so it is not a wall of fields. Each output gets its own universe. Give both outputs the same universe and you have a 1-in, 2-out splitter. Now the bit that trips people up, DMX, keeps repeating itself, so the box clocks the line even when nothing changes. The question is how fast. Continuous means it free runs at the rate you pick, which is what most nodes do. Delta means 1 frame out for every packet in, so the wire follows your console exactly. Why care if your console sends 33 frames a second and the node insists on 40? Some frames go out twice and moving head step instead of glide, so either match the rate or switch that output to delta and stop thinking about it. And this is not me guessing. There is a second board sitting at the far end of the cable that decodes the line and counts frames, breaks, and errors. That is how the timing gets tested, and it is what drove the render you saw at the start. Which brings me to RDM, and this is the big new thing. RDM lets the gateway talk back up the same cable and ask the fixtures who they are. You hit scan, and it walks the bus. This is a real scan of a real bus with 64 fixtures on it, sped up a bit. It runs 1 transaction per DMX frame, so your output does not stall while it works. And there they all are. Unique ID, model, manufacturer, which personality they are in, their DMX address, and how many slots they use. You can set the address from here, rename a fixture, or hit ID and watch the right one light up in the room. Fixtures also carry sensors, and those get graphed. Lamp temperature, supply voltage, fan speed, polling costs, bus time, so nothing is pulled until you switch it on. Per sensor. Leave one temperature on for a whole show and you can see the fixture that is slowly cooking. It is also a proper Art-Net RDM gateway, so this is not locked in my web page. A console or a diagnostic tool on the network can discover those same fixtures through the box, read them, and set them. Discovery is proxied. Get and set are passed straight through. Once a node is bolted into a truss, you do not want to dig out a laptop to change a universe. So there is an optional display and an optional knob and buttons that drive a tiny menu on it. Turn it, pick the universe, press Done, and it is saved. All of it is off until you actually set the pins, so a board without a knob pays nothing for it. The status LED speaks one language. Green means it is up. A slow blink means DMX is coming in. Blue is RDM. Orange means it fell back off Ethernet. Red means no network. You can give it a hostname, restart it from the browser, and point it at a firmware URL if you build your own. Updates come over the air, and you can pick any past release from a table, so if a new one annoys you, you go back. That is the tour. Firmware and hardware are open, and you can flash a board straight from your browser. No toolchain, no Python. Plug in USB and click. Links are in the description. Have fun with it.